Today we learn that a piece of string is smarter than D-marble. Now this flat earth proof is old. There was a flight from Taiwan to Los Angeles. On it, a woman gives birth. They have to divert the flight to Alaska. Now, flat earthers will tell you they should have diverted the flight to Hawaii, which is much closer to their flight path. And they prove this by showing the flight paths on a Mercator map, and then comparing it to the flight path on a Gleason's map.
So there's a China Airways flight from Bali to LA, and mid-flight a lady who's on board gives birth. She's 4 weeks premature, and they land in an emergency situation. And where do they land? Alaska. Now, none of this makes any sense whatsoever on a globe Earth, if I can duck out of the way in a moment. So this is the flight that they were supposed to take. This is their planned route across to LA. The problem is that when it comes to them taking this emergency landing at about this point in the flight, according to what they actually did, they took an enormous detour up to Alaska. Now, this isn't actually what happened. They just made an emergency landing. They just landed. And where did they land? Alaska. But on the flat earth map, we have a very reasonable explanation for this. So now we cut to how the route looks on, this is actually the azimuthal equidistant map. As you can probably see from what's going on behind me, there's where they land. And, you know, this makes nice, perfect sense. You'd go in a straight line if that's the most economical and efficient way of making the trip. So yeah, you can probably see that's where they stop. Doesn't make any sense unless you're on a flat map.
Ah, Nathan. Anyway, D-Marble made a similar video a while ago. It's still on his channel, so I'm guessing he still believes it's true.
The situation occurred on October 13, 2015, wherein a flight from Taiwan to LA had to make an emergency stop. But on a globe, as we'd expect, they didn't land exactly where we thought they would. They had to make their emergency landing in Alaska. Now, if you look at the globe model, you would see that they would just take off from Taiwan, fly across the North Pacific Ocean, and more than likely, the logical place to land would be Hawaii. And then they would go straight on to Los Angeles. But that's not what happened. They stopped in Alaska. Now, on a globe, you would see that a flight from Taiwan going to Alaska would more than likely just not really fit. It would look like they were taking a flight and would deviate far north where it didn't really make sense, and then they would have to fly a southern route back to Los Angeles. Whereas on a flat earth model, or the flat earth map, you can see that from Taiwan to Alaska to LA, well, it's pretty much a straight line. And that's a clue.
You're right, Daryl. It is a clue. It's a clue to the fact that you don't have a clue.
Now, these flight routes don't really work all that well on a globe, but you'll see that on a flat earth map, almost lines up perfectly from one point to another. And these are just clues. I'm not here to tell you what to think. I just want you to think.
So, Daryl, you want us to think. Okay, I'll tell you what I think. You... Anyway, we know Daryl owns a globe.
You're not supposed to be learning this because it's not real.
So you say those flight paths can't work on a globe. Well, you've got a globe. Have you actually tried it? Well, I did. It's a kindergarten level experiment. You get a piece of string, stick it on the globe. Daryl, let me know. If you want, I'll send you a piece of string and you can try it yourself. So, why do the flight paths work so well on the Gleason's map? There's a reason Northern Hemisphere flight plans match the Gleason's map so well. There's a clue in Gleason's original patent on page 2, lines 28 to 32. Gleason started with a globe and projected it to produce a matching two-dimensional version. That's why the flight paths match the Gleason's map. It was made from a globe. It was made from a globe that Gleason believed to be accurate. If he thought the globe was wrong or fake, why use it as a basis for his map? And I have to mention, Gleason's intention had nothing to do with map making, which is obvious by how incorrect it gets the further south you go. His patent was for a time chart for school kids and others to calculate the time difference between cities. The link is in the description. Read it, Daryl. So the question isn't how long is a piece of string. The question is, how far can Daryl stretch the truth?